An iconic passenger plane capable of carrying hundreds of people along with all their luggage. There are so many questions we could ask. How do they fly? How do they accelerate so quickly? But today we answer one of the most fascinating of all. How is such a feat of engineering built in the first place? To understand how the assembly process of Boeing's 747 has evolved, we must first take a brief jump back in history to explore how it became the superstar that it is today. The first ever plane to have coined the term jumbo jet was in fact the Boeing 747, an aircraft that was the result of lead engineer Joe Sutter abandoning development of a smaller 737 due to the increase in demand for air travel. Construction of this aircraft was unlike any other passenger jet. The long-range, wide-body jet went on to become the first twin-aisle airliner with a standard 343 configuration. September 30th, 1968 became the unofficial birthday of the 747, with the first example rolling out of the company's custom-built Everett Plant and the first flight taking place on February 9, 1969. Market leader Pan American World Airways subsequently placed an order for 25 747-100 variants, the first iteration of this jumbo jet, entering service on January 22, 1970. Various iterations of the 747 have resulted in what we know as the latest model today, the 747-8. The number 8 comes from the 787, which inspired this classic jumbo jet to go green. New General Electric GEnx engines make it the most efficient 747 the company has ever produced, aided by lighter and stronger materials all round. This helps the Model 8 achieve a range of 8,000 nautical miles, roughly the equivalent of 9,200 miles on the ground, which is a far cry from the original 747-100's 5,300 nautical mile range. Building these things must be a logistical nightmare then, right? Correct. To date, only 1,500 have been built since the 1960s, but it's hard to compare the production rate of a plane to the production rate of a car, for example. Timing is everything when it comes to assembling the latest 747-8. The pre-manufactured components all arrive at exactly the right time, leaving the workers with just the crucial job of putting it all together. On any given shift, of which there are 3 each day, there could be up to 10,000 employees working on site. While 50 or so cities were considered when deciding where to build Boeing's largest ever factory, the company ultimately decided on Everett, half an hour or so away from Seattle. Assembly of the first ever 747 went on as the building was constructed around the workers. Once complete, this building was, and remains today, the largest building by volume on the planet, at over 13.3 million cubic meters. That's the equivalent of more than 5,300 Olympic-sized swimming pools. Equal in height to an 11-story building, rumor has it that clouds have been known to form inside. Whether that's true or not, we're not sure. But what we do know about the building is that it's home to a network of internal roads and pedestrian crossings. Workers get from point to point by bike, while Boeing's own fire service is on standby at all times. A variety of high-street cafes provide refreshments and snacks for workers who forgot to take their packed lunches too. It takes workers months to learn the layout of the complex, which has a number of chambers dedicated to the assembly of each of Boeing's models. Companies would usually specify 366 passenger seats split across a primary deck and a partial upper deck. This upper deck only extended for a portion of the plane's length and was set back from the nose cone, allowing companies to use it as a freighter plane, adding a huge cargo door to the front end of the aircraft. A dedicated team would of course be in charge for the implementation of this huge door. Boeing saw the 747 playing a huge role in cargo transportation and expected supersonic transport to succeed regular aeroplanes when it came to the transportation of people. That would mean planes exceeding 768 miles per hour, something that decades later is yet to happen. This partial upper deck is what gave the 747 its distinctive hump that we're still familiar with today. Individual components are assembled all across the globe. Seats are sent in from Germany, wing elements from China, and wing flaps from Australia. But once the assembly process begins, nothing is automated. In finishing the process by hand, Boeing takes full responsibility ensuring that the plane is 100% safe for a lifetime in the air. The wings, for example, have thousands of fastening bolts which are individually tightened and double-checked by hand, not a robot in sight. The 747-8's wings are the largest ever built by Boeing, and they need to be just right, with each one holding 58 tons of fuel. That's enough to fill more than 1,000 cars in each wing. But then the 747 does like to burn around 10 tons of fuel per hour at cruising speed. In total, over a quarter of the factory's floor space is dedicated to assembling the wings. Unlike other models that Boeing and other manufacturers had built, the 747 featured wings that swept in a backward direction at 37.5 degrees. It's thanks to this that the plane could reach Mach 0.85, that's about 560 miles per hour in its early days. This also reduced the overall width or wingspan of the plane, allowing it to use existing hangars belonging to much smaller planes. A clever initiative by the design team, although a slightly more challenging mission for construction and assembly workers. Each 747 jigsaw is pieced together from three main pieces: the nose end, the midsection, and the rear end of the fuselage. These come together to form the body of the plane at the early hours of a morning to make sure that less workers are in the way of this vital moment of engineering. GE's quietest ever engines were deployed for this project, and precision during installation is key. Individually, they weigh 7 tons and cost $20 million, the most expensive component of the entire aeroplane. To ensure the plane is capable of handling such heavy machinery, before they arrive, Boeing hangs a series of oversized concrete blocks from each wing to imitate the weight of an engine. Maybe more painstaking is the 130 miles of wiring that goes into each assembly, which has to be checked one by a dedicated team. They carry enough electricity to power over 50 households. Finally, the plane gets its distinctive and personal look. Half a ton of paint is sprayed on once again by hand after an initial base coat to represent the carrier's colors, a long process that must be repeated every 4 years. The perfect amount of paint is calculated to maximize its longevity, without being too thick that vital signs of corrosion don't go undetected throughout its lifetime. Months of planning and less than 50 days of assembly result in the finished product, which is then subject to endless stress tests. These exhaustive and frankly extreme tests are designed to surpass safety requirements and include some radical moves, pulling as much as 2G mid-flight. Experienced staff must buckle in tightly, fastening even their laptops and research equipment. Next, water is pumped between a series of barrels to simulate different weight distributions that the plane may experience. Flutter tests in the air prove the plane's rigidity and airborne stability, while structural stability is proven with a slow takeoff, which forces the tail to rub against the runway, resulting in huge friction. If this wears a hole in the aeroplane's body, it's game over. A company engineer demonstrates how, should the hydraulic system that raises the flaps fail, a pneumatic system takes over, and should this fail, an electrical system should be used. So next time you board a flight and begin to worry about the unlikely event of something going wrong in the air, just remember, not a single robot is in charge of the build. Hundreds of man-hours and countless checks are just the start, and each aspect has been rigorously tested, while sufficient backups are always in place for the plane's crucial moving parts. Right now, Lufthansa owns the largest fleet of passenger 747s, but it's not just the average Joe that rides these machines. Did you know Air Force One, used to carry the American president and other VIPs, runs a pair of 747-200Bs and has already placed an order on the latest 747-8? While Boeing and other aeroplane manufacturers are going above and beyond to ensure the ultimate safety in their machines, it's come to light that many auto manufacturers may be cutting corners down here on solid ground, which begs the question: has aeroplane manufacturing set the gold standard for ultimate build quality, and should that become a target for all other manufacturers to aim for?